Okay, notice for this next example that I've broken out my little unit circle diagram here, but for now let's just figure out where this belongs in terms of the rectangular coordinates. So if we go back -1 and then a negative square root of 3, put this down here somewhere about there. And then here's the pole, and so the distance we're traveling along that angular direction is going to be calculated by the distance formula between this point and the origin 0, 0. So that would be a -1 minus 0 squared plus negative square root of 3 minus 0 squared. Okay, so we're going to end up with 1 plus 3, taking the square root of 4 to get 2. Okay, so we know that part of our polar coordinate. Got a 2 going here. Now we need the theta. We got to fill in the angle here. So what's this angle? Okay, let's take a tangent inverse. Now remember, for the tangent, it only works between -pi/2 pi/2. So whatever answer we get, we know it's going to be an angle that falls in that range. So we want the tangent of theta to equal y/x. So I've put a negative square root of 3 over -1, and that would end up being positive square root of 3. So our angle is equal to the inverse tangent of the square root of 3. Okay, and if your calculator is operating in degrees, you're going to see that's 60 degrees. So that's why I brought this out here. We can see that 60 degrees is right there. So this wants to tell us that the angle that we're interested in is 60 degrees, or pi/3. But the problem is we're in quadrant 3, so we can't be at the angle pi/3. But remember that the period on the tangent is pi. So if we move pi in this direction, halfway around from up here, we get to another point that has the same tangent. And what they're talking about here is this one here. Okay, so I've got 4pi/3, puts me in quadrant 3, and also has the same tangent, because here I'm taking negative square root of 3 over 2 divided by -1/2, and that would be positive square root of 3, and this would also be positive square root of 3. So the two angles that have a positive square root of 3 for their tangent are pi/3 and 4pi/3, but we need this to be in quadrant 3 because of the coordinate we started with. We know that, so we're going to use 4pi/3. So there's our angle. So the polar coordinate that matches this rectangular coordinate is 2, and along the angle 4pi/3. Now there is a way to use the angle that our tangent gave us, pi/3. If I wanted to do that, and I go this angle, remember I can go to that angle and then go in the opposite direction by r. So I could change this 2 to a -2. And if I go this direction and then -2, taking me down there, I would write an equivalent -2 traveling from the angle pi/3. Okay, here's a nice summary of what's happening when we're finding the polar coordinates for rectangular coordinates. If I'm in quadrant 1, as in this example here, I'm going to take and find my theta directly by the inverse tangent. No change is necessary. And this is all because the tangent is defined between, the inverse tangent is defined between -pi/2 and pi/2. So here's the other place where I can just take it as I get it, inverse tangent. Now, when I'm in one of these other quadrants, either here or here, I'm going to have to adjust it by using the period of the tangent, which is pi, and add that period to move it over to the other side where the inverse tangent is defined. So you'll still just take your inverse tangent with y over x, but it's going to give you the wrong theta, and you can fix it by adding a half circle back into the quadrant that your actual point came from. R is no problem because it's the same across the board, so it's just going to be the square root of x squared plus y squared.